So let's talk about statics. So what is actually meant by statics? So statics means that the body is actually at rest, and the force and the forces acting on it are actually in equilibrium. So the body which is at the stationary condition, and there is no resultant force acting on the object. So this means that the body is actually at the static condition. So this is what we meant by statics. Okay, so let's talk about center of gravity. So what is actually meant by center of gravity? Okay, so let me draw a book here. So this is my book. So this is a book. Okay, we know that the center of masses for these books is actually at the center, right? Okay, so this is the center of mass, which is denoted as X. Okay, so this center of mass will give us the weight mg, and at the same time this center of masses is where the center of gravity located. So this is for the regular object. And let's say I have a meter rule here. So this meter rule is about 50 cm long. So as for the center of gravity for this meter rule is actually at 7.50, which is at the center of the meter rule. So this will give us our center of gravity. Okay, so this is for the regular object. Okay, so based on this concept, we know that center of mass is actually equals to center of gravity. As for this concept, is also is only applicable for the situation where we're in uniform gravitational field. So our planet Earth has a uniform gravitational field. So this will give us the concept based on the center of mass is actually equals to the center of gravity. Okay, so this concept is always applicable for regular object and non-regular object. Okay, so this is how we determine the center of gravity. Okay. So what if we have a non-regular object? Regular object. So let's say I have a cupboard here. This is a cupboard. Okay, so this cupboard, we know that the center of masses is always equal to the center of gravity. But in this cupboard, which is non-regular shape, the center of mass of everywhere is not equally divided. So it is hard for us to determine the center of masses where the center of gravity located. Okay, so there's another way we are able to find the center of gravity for this non-regular object. Okay, so the first step to determine this to determine the center of gravity for this object. Okay, so the first step is we have a pin here. So this pin is from this side to the other side. Okay, so this pin is tied to a string, and this string is tied to a bob, which is mg. So this pin, we have this pin, and this pin is tied to the string. Okay, the way we need to mark the position for this string is we use the marker pen to record the position of this string. Okay, so this is for the first step. As for the second step, so we rotate, let's say we rotate this cardboard to horizontal position. Okay, let us choose the point. Okay, so this is our point that we chose, and we use this pin to record it at here. So this is our second point, and the first mark from the first step of this experiment, we can see that the first mark denoted as the dotted line is at this position. As for the second step, which is also the same step, so this is our string and this is our bob, and we use the marker pen to mark the position of this string again. So this is our second mark for one of the point in this cardboard. Okay, so let's move on to the third step. So let's say I set this object in this position. Okay, so we can see that from the first step and the second step of this experiment, we can see that this is the marks from the previous steps. Okay, so let me choose this at the third point. Okay, so I pin it here as a record. Okay, so this is my string, so I mark it here. So this is my bob, which is mg. Okay, as you can see that from this first line, second line, and the third line, we can see that these lines are always intersecting at one point. So this is our point of intersection. So this point of intersection will eventually give us the center of gravity. So this is how we determine the center of gravity for non-regular object, which I consider more easier way for us to determine the center of mass or the center of gravity for the non-regular object. Okay, so let me erase this one. As for another way to determine the center of gravity is by using the calculation. Okay, so we know that the center of gravity or the center of mass, so which is the mean x coordinate, so it's actually given as x1 plus w2 x2 plus w3 x3 and so on, plus wn xn. So this w is the number of atoms. So x is the coordinate for the point where the coordinate of that mass located. And okay, so this total, the sum of this total is divided by the total number of atoms plus until wn. So this is the coordinate for coordinate x, which is the center of gravity or center of mass. Okay, as for the mean y, so this is our y position. So same formula, y2 plus until wn xn. Okay, so this is 1, this is 2, and until wn. Okay, so this is the way we calculate for the center of gravity. There's a mistake here. Okay, and this w is actually not the number of atoms, and this w is actually the frequency of x and y. So this frequency of x1 plus this frequency times x2 and so on, divided by the frequency, all the frequency, and usually we will get the sum of wi xi, which we simplify it, and this n, and this is 1 divided by wi, so this is 1 and this is n. Okay, so this will be the frequency, so I apologize for my mistakes, and this is also the same. So this is how we use the calculation method to determine the center of gravity or the center of mass. Okay, so of course the center of gravity is actually equals to mean x and mean y. So this is the coordinate for the center of gravity. Okay, so let's move to the next part. So let me erase this one. And this one as well. Okay, so let's talk about forces in equilibrium. So firstly, we need to know that what is actually the coplanar force, and what is the definition for coplanar force and concurrent force. force. So let's say I have a mass M. So this mass M is actually tied to a ceiling. So this is and is tied through the by two string. So this string will give us the tension 1 and tension 2, and this one is our weight of the object. Okay, so this T1 is pointing upward, and this one will be pointing to the right, and this one is the left. Okay, as we can see that in order to let this object to be in equilibrium, and there is a three forces acting at the same time and also at the same plane. So so the meaning of the same plane, it means that, so this is the y-axis and this is x-axis, so this is T2 and this is T1, and this is our mg. So this is what we meant by the same plane, and at the same time these three forces is acting on this mass. So this is what we call coplanar force. Okay, so this is the forces acting on mass M on the same plane at the same time oops at the same time okay, so this is the definition for coplanar force: the forces acting on mass M on the same plane and at the same time. Okay, so what is actually the concurrent force means? Okay, so we know that this is the center of the mass. So this is the center of the mass. So okay, let me erase this one. So we know that this is the center of our object, and I represent it in this diagram. So this is the center of mass, and we can see that there is always an intersection point between these three forces. So this is what we call the concurrent force. Okay, so the concurrent force is actually meant by the lines of all forces pass through the same point. It's always pass through the same point. Okay, so this is what we call concurrent force. Okay, so let me erase this one. Okay, so we know that, so we already understand what is the coplanar force and concurrent force. So let us okay, let me draw a bigger diagram here. So this is mass M, so this is tension 2 and this is tension 1, this is mg. So let me erase all this one. Okay, we can see that the the object is actually in static condition. It means that static condition means that, as we mentioned just now, so static condition is where the force is in equilibrium and the mass is in stationary condition. So we can see that the tension 1, tension 2, and the weight of the object acting on the object, but the object is actually in stationary, and there is no resultant force acting on the object, which by saying that T1, T2, and mg is cancelling each other, so this will give us the static condition for the object. Okay, so this is how we determine whether the object is in equilibrium. So we can conclude that these three forces is actually in equilibrium. Okay, so what if I represent these three forces in terms of vector diagram? Okay, so this is my T2. So this is my T2. Okay, so this is my T1. Okay, so this is my T1. Oops, okay. So this is actually my mg. Okay, so this is my mg and this is T2 and this is T1. Okay, as you can see that these three forces in terms of vector diagram, okay, this should be attached. Okay, so these forces acting on this diagram, which is the equilibrium, so the equilibrium forces in terms of vector diagram is rotatable. So we can see that the direction of these three forces is actually in anti-clockwise. Is it anti? Oh yes. So this is the anti-clockwise for these three forces. So if there is anti-clockwise direction, anti-clockwise or clockwise direction for the forces in vector diagram hence the object is in equilibrium. So this anti-clockwise direction show us that the object is actually in equilibrium condition. So if the object is not in equilibrium, so basically the forces acting on the object F2, okay, will give us the resultant force. So this resultant force show us that the object is actually not in equilibrium condition by saying that the object exerts translational motion. Okay, so let me give an example. So let me erase this one. So what is meant by this statement? Okay, so let's say I have a mass M. So this one is F1 and this one is F2. So if F2 is more than F1, so F2 minus F1 will give us the resultant force. This means that this object is about to move backwards. So this will give us the resultant force, and this one will be our vector diagram. So this means that the force is actually not in equilibrium. So this is how we determine whether the force is in equilibrium or not. Okay, so let's move to the next part. Okay, so let me erase this one. So this one as well. Okay. Okay, so what if there is more than, so this is our mass M. So what if there is more than 3 forces acting on the object? Okay, let's say I have this, and this one, this one, this one, this one, this one, and this one. So this is our F1, F2, F3, F4, F5, F6, F7, and lastly will be F8. And let's say we have these 8 forces acting on the object. So in terms of vector diagram, we can know that, okay, so this is our F1 and this is F2, so this is F3. Okay, so this will be our F4, so this is F5, so this is F6, so this will be our F7, and finally F8. And this shows us that the direction of these forces is actually in clockwise direction. So this vector diagram represents as the polygon shape, by saying that the direction of these forces is anti-clockwise. So this vector diagram can be represented as the polygon shape, which is octagon. So these forces can be represented as in terms of octagon shape. So it means that if there is an clockwise direction, it means that the forces is also in equilibrium. So this is how we determine the equilibrium forces if there is more than 3 or 4 forces acting on the object. Okay, so let's move to the next part. Okay, let me erase this one. Okay, so let's move towards the equilibrium of the rigid body. Okay, so let's say I have a plank here. So this is my plank, which is a slide plank. So this plank, we know that the center of gravity of this plank is at the middle. Okay, so let's say I draw a dotted line here. Okay, so this will be our R, and this will be our direction of the force. So this is theta. Okay, based on this diagram, we can know that the distance, okay, we can define the definition for the thought by saying that thought is actually the cross product between the distance, the direction of the distance of the plank, and the force acting on the plank. Okay, so this is the direction for the force. Okay, let me explain it in terms of qualitative answer. So thought is defined as the cross product of vectors R and F. So cross product, it means that R, F is sine theta. So this is sine theta, and if theta is actually equals to 90 degree, so thought is actually RF. By saying that, okay, so let me draw a horizontal plank. So this is the center, and this is the distance. This is the distance between the pivot of the plank and the force. So we can see that the distance and the force, if the distance and the force is perpendicular, so this force is pointing downwards and this distance is pointing to here. So this will eventually give us the resultant torque. So this will give us the rotation. Okay, so this will eventually give us the rotational motion for the plank if the force and the distance is perpendicular. Okay, so let me erase this one. Okay, this one as well. Okay, so let me erase this one as well. So as we discussed just now, the torque is actually the cross product between the distance from the pivot to the force, okay, times the applied force, or we can say that torque is actually RF sine theta. So what if theta is actually equals to 0 degree? Hence, so the torque given this one, sine 0 degree, is actually equals to 0. So it means that if, okay, let me draw a plank here. It means that if the distance, if the direction of the distance and the applied force is parallel, so this is the direction for the distance between the pivot and the force. So if the force is parallel to the distance, direction of the distance of the plank, so this will not give us the rotational motion, by saying that torque is actually equals to 0. So this is how we determine the definition for the torque, okay, by saying that torque is actually the cross product of vector r and f. Okay, so that is the definition for torque. Okay, so let me erase this one and erase this one. So as we discussed just now, so okay, there's a translational motion and rotational motion, as we discussed from the previous parts. So if there is no translational motion, it means that the object is actually in equilibrium or stationary condition. So F is in equilibrium, object stationary. As for the rotational motion, so if there is no rotational motion, we can conclude that the resultant torque, which is the cross product of F and R, or Fr sine theta, is actually equals to 0. So from these two concepts, we can finally conclude that okay, let me erase this one. Okay, we can finally conclude that the condition for the equilibrium of the rigid body we can conclude that for the first one, the resultant force acting on the body is actually equals to 0. As for the second conclusion, we can conclude that so the resultant force the resultant torque about the axis of rotation is actually equals to 0. So this is the condition for the equilibrium of the rigid body, by saying that if the resultant force acting on the body is equal to 0, by saying that there is no translational motion. And for the second conclusion, the resultant torque about the axis of rotation is equal to 0. It means that there is no the rotational motion. If there is no motion and the object is in stationary condition, and okay, so the object is in stationary condition, so we can say that the object is actually in static condition. So that is the explanation for statics. Okay, so that's it for the static chapter. Okay, I hope you can understand further and after watching this video. So if there's any question need to be asked, please comment below of this video. Okay, so I think we stop here. Okay, so thank you. Bye.